When a secret is found in a repository, the immediate response is to revoke it and generate a new one. The specific system, the secret authenticated to, gets secured. The exposure is treated as contained. What almost never gets asked in that moment is whether the same value was used anywhere else. Secret reuse is the property that converts a single exposure into multiple simultaneous compromises, and it is structurally encouraged by the same pressures that produce every other secret management failure. Not carelessness, not ignorance. The practical friction of managing credentials in complex systems. Consider what credential management looks like at the level of an individual developer. They are building a service that needs to read from a database, call an external API, push to a message queue, and write to a file storage service. Each of those requires a credential. Each credential needs to be present in the development environment, the staging environment, and the production environment. Each environment needs its own copy. That is 12 credentials to manage before the service has a single line of application logic. The developer who uses the same database password across development, staging, and production has reduced that to 10. The developer who reuses an existing API key they already have configured has reduced it further. Each reduction feels like pragmatism. Together, they produce an identity graph where a single exposed value has edges to multiple systems. The blast radius of a secret exposure is determined by the number of systems that accept the exposed value as valid authentication. A secret used in one place has a blast radius of 1. A secret used across 12 services, 3 environments, and 2 external integrations has a blast radius that was never deliberately designed, never documented, and is rarely fully understood by anyone until an incident forces the question. Database credentials are the most common site of this pattern. A single database password, shared across multiple applications, multiple environments, and sometimes multiple databases, produces a situation where rotating the credential requires coordinating every service that holds it. The coordination cost is high enough that rotation gets deferred. The deferral means the credential ages. The older a credential, the more likely it has been seen by more people, stored in more places, and committed to more configuration files. The reuse that made management easier at the start makes remediation harder at every point that follows. The infrastructure as code ecosystem has introduced a specific reuse pattern that most teams have not fully modeled. Terraform, Ansible, Pulumi, and their equivalents require credentials to provision infrastructure, cloud provider access keys, API tokens, service account credentials. Those credentials are frequently the most powerful in the entire environment. They are capable of creating new resources, modifying access policies, and in many cases generating new credentials for other systems. A single infrastructure automation credential that is reused across multiple pipelines, multiple repositories, and multiple team environments is a single point of failure that, if compromised, provides leverage over the entire infrastructure rather than any individual service. Webhook secrets illustrate a quieter form of reuse. A webhook secret is a shared value that a service uses to sign outbound requests so the receiver can verify they came from the right source. They are issued per integration, in principle. In practice, many organizations configure the same webhook secret across multiple integrations because the systems that receive webhooks are configured manually, one at a time, and reusing a known working value is faster than generating and distributing a new one. When an attacker obtains that secret, they can forge events to every receiver that accepts it. They do not need to compromise the sending service. They just need the value that all the receiving services trust. The aggregation risk of secret reuse is most severe in the context of credential stuffing. When an attacker finds a valid credential in one place, a repository, a log file, a leaked database, the first thing automated tooling does is test it against a list of targets. Not because the attacker knows the credential is reused, because the base rate of reuse across real systems is high enough that testing is always worth the cost. The credential that was found in a development environment config file that the team considered low risk because development data is not sensitive may authenticate to the staging environment, which has a copy of production data taken 2 weeks ago for testing purposes, which has never been through the same access control review as production. The defense against secret reuse is unique credentials per service, per environment, per purpose. That sounds obvious. The reason it does not happen by default is that generating, distributing, storing, and rotating unique credentials for every combination of service, environment, and integration is operationally expensive without tooling designed for it. A secrets manager with dynamic credential generation, where the secrets manager creates short-lived credentials on demand for each requesting service rather than issuing static credentials that get copied everywhere, eliminates the reuse pattern at the infrastructure level rather than relying on credential hygiene at the developer level. Dynamic secrets work by inverting the credential model. Instead of a credential being generated once and then distributed to the systems that need it, a credential is generated fresh each time a system requests it, scoped to exactly what that system needs, and expires when the task is complete. The database password used by the 2 a.m. batch job is different from the database password used by the web application handling the 9 a.m. traffic spike. Neither is the same as the password used by the analytics pipeline. Each was valid for minutes or hours. None of them were ever stored anywhere except in the memory of the requesting process for the duration of the operation that needed them. In that model, there is no static credential to reuse. There is no blast radius that extends across systems because no system holds a credential that authenticates to any other system. Each access event is independently scoped, independently expiring, and independently auditable. Secret reuse is not a behavior pattern to correct. It is an architecture pattern to replace. The organizations that have the fewest secret reuse incidents are not the ones with the best credential hygiene policies. They are the ones that built systems where reuse is structurally impossible because the credential architecture never produces a value worth reusing.